Okay, guys. So let's start the session. In today's class, we are going to discuss the next topic called as regression. Okay, regression. Now, in today's class, we are going to understand the regression. What is the math behind the regression? And how the machines will learn the regression, that is machine learning algorithms. How the machine learning algorithm is applied over data. Machine learning algorithm, how the machine learning algorithm was applied on data. And also we are going to understand the third one is what is the Python code, how to execute this same regression project using the Python. We are going to see what is the Python coding part and what is the maths behind the regression. Okay, done. So now coming to the regression, what are the maths behind and machine learning algorithm, how it is going to apply and what is the Python code, all these things we are going to see one by one. To understand the regression, first we should understand what is regression. And from there, we'll start everything. Now, what is regression? Regression means where we are going to predict the output variable, where we are going to predict the variable or predict the variable or future, which is continuous, or in brackets simply numeric, which is numerical value. So what is regression means the process of prediction. What are the process of prediction? The variable or future which is continuous. It is called as a regression project. Okay. Now, so here as an example, multiple examples we are going to discuss, and we are going to see what is the max behind that. So here the examples where we are going to predict the house price, predicting the house price for the future data based on the past data, predicting the house price, used car price, sales, what would be the estimated sales. And like this for everything, these are all the numerical data which we are going to estimate. Okay, what would be these values? So whichever we are estimating the data which is numeric, that we call it as, that one we call it as regression. Okay. Now coming back, so these are the just as an examples. Even if you have to estimate the AI engineer salary, what are the AI engineer or ML engineer's salary? What is the salary based on the skills and based on the other input futures we want to estimate. So just estimating estimating the variable or future which is continuous is called as regression. Now, so here regression means estimation. Now, what is this estimation? How we are going to estimate? Question number 2 is how we estimate. How we estimate. That is the question. Now, for that particular question, we are going to estimate. We estimate based on the pattern, based on pattern of given data. So in the given data, we'll identify the pattern, and from that pattern, we are going to estimate the futuristic data. Let's assume this. We are having the two columns. One column is I, second column is O. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This we call it as given data. This is our data was given to us. Okay, this is the data was given to us. Now we have to estimate. Based on this, we have to estimate. Given is this one. We have to estimate this one. We have to estimate for I value 6. What would be the O value? Now you have to estimate on the new data. What are the new data which is unknown data for you? Okay, this data is unknown. In this given data, this data is not there. Just what are the given unknown data, we have to estimate the output. This we call it as I means nothing but input. And based on the input and output, based on the input, we have to estimate the output. Right? So this is the given data. We estimate based on the pattern of the given data. What are the pattern we have identified? So first, what is the how we are going to work like this? First, we are going to identify the pattern. Okay, first, what is the first step we are going to do, miss? First, we are going to identify the pattern. First, identify the pattern. What are the pattern is it? The pattern in given data. What is the pattern, miss? Nothing but identifying the pattern means nothing but identifying the relation. What is meant by identifying the pattern means identifying the relation between variables. Okay, variables. Like example for this one is in the above example, identifying the what are the above example you are having. In the above example, identify what is the relation, what is a relation between X and Y or input and output. Those are the two column names. So two columns are given means we'll identify the relation between two. Three columns are given means we identify relation between three. 10 columns are given means 10 columns relation. So what are the relation is there? So in the above example, we'll identify the relation between the input and output. What are the given two columns are there? We'll identify the relation. So generally the input data, what are the input is there? IP. That input we represent by X. Output will be represented by Y. So here we are going to identify the relation between X and Y. What is the relation between X and Y? That relation for the future data we cannot try. We have to estimate for the past data. For the past data, first we'll identify the relation and that relation will apply for the future data. So first I'm going to identify the relation. What are the relation is there? First I'll identify. In this above example, what is the relation is? The relation is Y is equal to X plus 5. That is a relation. So every Y value, what are the Y value is there here? Every Y value in this example, every Y value is equal to X plus Y, X plus 5. If you observe, every value of Y is equal to X plus 5. Means what are the X values there? Plus 5 is our Y value. So here, just we are going to have Y is equal to X plus 5 is the relation we have identified. Once we have identified the relation, what are the relation we have identified? This in a general English, we call it as relation. The same thing we call it as model. Model means identifying some equation, the relation between the X and Y. Model means nothing but equation. Every model will consist of equation only. The equation which consists of numbers. And model means basically numbers, equation numbers. So here we are having the equation like this, 1x plus 5. So that, sir, 1x plus 5 is relation or model? Relation is general English word. Model is as per the ML word. ML and AI, it is called as model. Both are same, basically. Okay, relation and model, both are same. So here identifying the model. Model means what? Equation. What equation? The relation between these. Once you have identified the model or equation or relation, what are the equation is there? Relation, equation, model, all of them are same. No difference. Once you have identified the relation, for the future data, we are just substituting the new X value in this equation. That is 1 into 6 plus 5, which is 11. This is the estimated value. Like this, we are going to estimate. So for estimation, how we are going to do? Two steps. One is identify the relation. And once we have identified the relation, for the future data, what are the future data is there? For future data, substitute. For future data, just substitute the input. Just you are going to substitute the data in the equation. The data in the equation. And we are going to estimate and estimate. Okay, so once the equation was identified for the future data, just you are going to substitute that and we are going to calculate. Is the point is clear? So how the estimations will be done is very simple. Just we are identifying the relation between them, and after identifying the relation, we are just substituting. Example number 2. Okay, with one example, we can't understand everything perfectly, right? Example number 2. Now my example number 2, where I'm having one more example like this. X and Y. 1, 2, 3, 4, 5. 1, 4, 9, 16, 25. Okay, this is the data. What data? Given data. Always remember given data. We have to estimate for the future data. For the future data, input is available, but output is not available. Okay, this is not there. This is what we have to estimate. This is called as future data. Sir, in the real life, you tell with one more example. Same example in the real life. For example, based on the number of kilometers driven of the car. Okay, one car is there. Let's take only one input column. The column name is called as number of kilometers driven. 50,000 kilometers driven, one car. What is the price of that car? Okay, the price of that car is 6 lakhs. Used car price is 6 lakhs. One car was driven 60,000 kilometers. What is the car price? Miss 5,80,000. Sir, here car model and car year of manufacturing and car color, like this multiple parameters will be there now, sir. They are not there. They have given only this one. So based on this one, we'll identify the relation. If you give me multiple columns, I'll apply all the multiple columns relation. If you give me only one column, I'll apply only one column logic. Okay. So for example, 70,000 was given and here you have given the 5,60,000. Something like this you have given. Now you are asking for the future data. If number of kilometers is equal to 80,000 kilometers, then what is the value of this price, miss? Just based on the relation, I'll identify the relation and based on this, I'll say this is 5,40,000. For every 10,000 kilometers, 20,000 price is reducing. That is the which I have observed on the given data. I have estimated on the future data. Basically for future data, I don't know. Without giving the past data, directly if you ask this question, what I will have to tell? Answer is what? What is future value miss? How I have to tell the future value? So first you give me the past. In that past, I'll identify the relation. And once I have identified the relation, then I'll tell you what is the one. So now they have given this data to me and they're asking for this, what is the estimated value? So for this data, first I'll identify the relation. What is the relation miss? Y is equal to 1x square. That is 1 into x squared. Every x value square is y. This is the relation I have identified. Now tell me for the future data, what would be the estimated value? This is called as estimate. Estimate symbol is like this. This is actual. This is estimate. Now how we are going to estimate for the future data is y hat is equal to estimated y value is 1 into x square. In that x, I'm going to substitute the 6. 6 square, that is 36. That is the estimated value. Estimated value. Sir, these are the simple examples, sir. Because you have taken the one example, second one is simple. These are the simple examples. Now, whether it is a simple data or whether it is a complex data, finally what we have to do is steps are common. What is the step? Step 1 is identify the relation. Step 2 is substitute the future data in that. Just you are going to substitute the input data in that. Output we are not going to substitute because output only we don't know. Substitute what are the input is there? Input into that, into the relation or equation or whatever it is. And you estimate. Substituting that one is nothing but estimation, which is also called as prediction. Right? Now, who is going to become the next Chief Minister of Telangana? If, for example, some Telangana elections are going on right now, who is going to become the Chief Minister? Miss, to whom do you have to ask this question? Whoever is having the knowledge on the politics, who is having this knowledge on the survey, presently who is having the data with the survey reports. For this person, they can estimate. If you ask to a roadside person who is going to be the Telangana CM is, he will estimate with the data randomly. Estimation everyone will do. I will also, for any data set, without giving the past data, ask me, sir, for 6, what is the estimated value? You ask me this question, I will also tell 10, I will tell 11, I will say 15. My random number, na. This random number is, this is random number. Randomly, we are going to predict. What would be the today temperature? What would be the tomorrow's temperature? What is the after 1 year temperature? What is the NASA is going to do tomorrow? Everything I can estimate. But that estimation should have the proper thing, miss. Good accuracy should be there. Good accuracy should be missed. Past data should be there. But the past data, first we have to identify the relation. Without having the past data with us, without having the data, if you randomly give something prediction, that we call it as luck prediction, random prediction. It may work, it may not work. Is the point is clear? Everyone? Understood, guys? Now, so here, the how we are going to predict miss in this way. First, we have to identify. Now, for identifying that only, here we are having the, sir, for the given data, see, for example, above is there. This is the first example. I have taken the 2 examples, guys. I'm writing the 2 examples one more time here. Just my previous examples only. Example number 1. X 1, 2, 3, 4, 5. Y 6, 7, 8, 9, 10. Example number 2. X 1, 2, 3, 4, 5. Y is 1, 4, 9, 16, 25. These are the 2 examples which I have considered. First example, second example. Sir, you are having the infinite number of equations are there, right? Why you have selected this equation only? Infinite equations are there, na? You can write even y hat is equal to 6x minus 9 also. 4x square plus 3x minus 4 divided by x plus 9 also you can write. Infinite equations are there, na? How you have identified this one only? Or for this one, what you told is one is y is equal to x square. Why x square only? Why it can't be x cube? Why it can't be with respect to the power of 4 plus 4x square plus 9? Why it can't be? Or minus 9? Why it can't be? Why this one only should be there? Yes, here, answer is very simple. Out of infinite equations, which equation is more having the accuracy? That one. Sir, what is meant by accuracy, sir? More close to the prediction. I mean, actual answers. So, what is meant by accuracy or what is meant by error? What is meant by accuracy or error means the closeness. Okay. The comparison between, simple to say, comparison between actual values versus predicted values. Comparison between actual and predicted values is called as accuracy. Comparison between actual values versus predicted values is called as accuracy or this error. Okay. Now, so after once, for example, you are going to learn the machine learning under me. After the machine learning was completed, I'm going to conduct a test. In the test, the questions will be there. First question, second question, third question, fourth question, like this questions will be there. For every question is there. Question means which we call it as input. Okay, for every one question, you are going to estimate the output. That is nothing but answer. This is actual answer or predicted answer? Actual or predicted? Means this is predicted by you. You estimated. This would be the answer you estimated. These are all the estimated values. In the question, once you have given the question paper and once you write the answers, all are called as prediction, which you have predicted or which you have estimated. If your estimation is correct, means I will make the correct and I will give the marks according to that. For example, I have given the 4 questions. For these 4 questions, I have given the options A, B, C, D, like my MCQ. A, B, C, D I have given. And in the A, B, C, D, for the first question, second question, and third question, and fourth question, for the first question, you estimated for the given first question, out of A, B, C, D, which is the correct option? Out of A, B, C, D, which is the correct option means you told that A from your point of view. Other person, they write B also. That is from their point of view. So these are all the estimated values. First question, you estimated A. Second one is A. Third one is C, followed by B. You estimated like this. Now, what is the marks? How many marks you have got for these 4 questions? Out of 4, how many of them are correct? How many marks you have got means? Now, this is estimated values, but I require the original values, that is actual values. If actual values is A, B, C, and B, this is the actual. Now, how many marks you have got? 3 marks. How you are saying? Comparison between the actual versus predicted. Since both of them are same, it is called as correct. This is called as wrong. This is correct and this is correct. Out of 3, out of 4. This we call it as evaluation. What is this is called as? Evaluation. Writing the answers for your questions is called as prediction. And I am comparing that one with the original answers is called as evaluation. Even in the ML also, the same thing will be done. ML is not special. In ML also, you are going to predict the values, and that values we are going to compare with the actual values. Okay, like this, it is going to work. Is the point is clear, guys? Everyone, till now. So, here Sai is asking the question, sir, evaluation repeat. Evaluation means nothing but comparison between the comparison between the actual and predicted values is called as evaluation. Evaluation meaning means comparison between actual and predicted values. So model is going to predict or human is going to predict something they are going to predict. Whatever they have predicted, the prediction versus actual is called as this. Now, let's take an example. One more example so that you will get a complete clarity on this. The same previous example. Okay. X 1, 2, 3, 4, 5. Y 6, 7, 8, 9, 10. Now, any student other than 1x plus 5, tell me any one equation. Choice is yours. Which are the equation you are interested? Choice. Blindly you give me. 2x, 2x square. As one of the student is giving the 2x square. Now, this is one equation. Equation number 1. One more student, please give me one more equation other than 1x plus 5. Okay, one more student is giving the x plus 9. And one more student, please give me one more. Let us go with the online students. Online students saying that Indra is saying that 2x plus z. Don't go with Indra. 2x plus z. Z is unknown. Na? Something. You can't take that z. Okay. So here how the equation should be there means your output should be on the left side. Right side it should have the only the input column. In the entire right side only input column variable should be there. Outside output side you should have the means your equation formation should be such a way y is equal to f of x. Y is equal to f of x. What is meant by y means y is equal to some equation which is dependent on the x. In this entire one, only x should be there in the entire equation. You may take 2x squared plus 4x minus 9. You may take 9x squared plus minus 1. Anything is fine. But in the right side equation, what should be there? Only x should be there. If a mathematical equation completely depending only on the x, that mathematical equation we call it as f of x. So, for example, 2x squared plus 5z is there. Y is equal to like this, 2x squared plus 5z. Then this equation is represented by f of x comma z. Means your f is dependent on the x variable and along with the z value. Both the values it is dependent. Is the point is clear? Y is dependent on the x and z. Whereas y is dependent only on the x. That this is the mathematical representation. Any equation, anything. Is the point is clear, guys? Understood the logic of mathematical representation? Now, so here I'm having one more equation. One more student from the online is giving the one more equation. That is, Joshi is giving 4x plus 2. Done. Okay, 3 students has given the 3 equations. Along with the one more equation is x plus 5. Okay, all of them y is equal to only. Obviously, y is equal to. Y is equal to, y is equal to, y is equal to, y is equal to. Here also y is equal to f of x only, means your entire y is dependent only on the x variable. Okay, just if you give any x value, automatically y will be calculated. So y is equal to x plus 9. Here also y is x plus y of x. Okay, f of x and y is equal to f of x. In all these cases, y is equal to f of x. Now my question is, here you are having the 4 equations are there. Out of these 4 equations, which equation is best? 4 are there now. Which one is best? Which one is best out of these 4? How to calculate that? So for everything, just estimate the y values. This is actual values. Whatever the data set was given to you is called as actual. Whatever the equation you have identified something, that we call it as equation or model. Okay, using this model, just we are going to substitute the x value here. When I substitute 1 here, what is the y value? Y is equal to 2x square. That is 2 into 1 square. 2 into 1 square is 2 into 1 square is 1. 2 into 1 is 2. Okay. Next, y is equal to 2. I am substituting. When I substitute the x is equal to 2 here, 2 square is what? 4. 4 into 2 is 8. 3 I substitute. 3 square. What is 3 square? 9. 9 into 2 is 18. Okay. Next, 4. 4 square is 16. 16 into 2 is 32. 5 into 5 square, 25. 25 into 2 is 50. Now, here these are the estimated values. These are estimated values based on this equation. Now, one more. Based on this equation, tell me what is the estimated values, everyone? In the same way, tell me estimated values for this. Based on this equation. What is the estimated values? You are going to substitute 1 here. 1 plus 9. 1 plus 9 is 10. 2 plus 9, 11. 3 plus 9, 12. 4 plus 9, 13. 5 plus 9, 14. This is the estimated values. For this one, what is the estimated values? If this is the equation, in this case, what is the estimated values? 1 into 4, 4 plus 2, 6. 4 into 2, 8. 8 plus 2, 8 plus 2 is 10. 3 into 4, 12. 12 plus 2 is 14, 18, and this is 22. And here, y hat for this equation is 6, 7, 8, 9, 10. For 1 equation, 1 estimated values are there. 1 equation, 1 estimated values are there. Is that clear, everyone? Understood or not? For 1 equation, 1 estimated values are there. Everyone is clear up to here? Anyone has any doubts? Now, out of these 4 equations or 4 models, as per ML, they are called as models. As per Max, it is called as equations. Out of 4 equations, which equation is best? Which one is very close to the actual values? That is the best. How to check which is close to actual values? Means we are going to calculate the error. Error means nothing but y minus y hat. What is y minus y hat means? Just we are going to actual value minus predicted value. If actual value and predicted value, the difference is very less, your prediction is more accurate. Actual value is 600. You predicted 900. What is the difference? 300 difference you have predicted. Actual value is 600, but you predicted 610. What is the meaning of this? Difference is 10. Actual value is 600. Your predicted is also 600. Now what happens? Error is going to become the 0. Means perfectly you have predicted. So what we required at the end? Error to be minimum. What we required? Error minimum. So out of here 4 equations, which equation has given me the error as minimum? That is the best equation. Is the point is clear? The logic understood, everyone? Yes or no? Everyone please confirm. Out of infinite number of equations, which equation has given the error minimum? What is meant by error? The comparison between the actual versus predicted. So comparison means we have to compare like this, or we have to compare the difference. Sir, here 2 is there, here 6 is there. Wrong prediction. 7 is there, 8 is there. Wrong. 8 is there, 18 is there. Wrong. 9 is there, 32. 10 is there, 50. Wrong. All of them are wrongly predicted. Should we do like this? Or 6 minus 2, 4. 7 minus 8, minus 1. 8 minus 18, minus 10. 9 minus 32, which is equal to 23. 10 minus 50, which is minus 40. Should we calculate like this, or should we say like this? Means this is applicable for the text data. This is applicable for the numerical data. That is the difference. Okay. See, when you are having the two numbers, original is number and predicted also number, then we have to go with the difference. That difference we call it as errors. Actual is number, numeric. Predicted also numeric. That is also number. Then what we have to calculate? Error. That is the difference. Nothing but difference between those two. Actual is not number. Actual is text. Predicted also text. Then what we have to calculate in this case? Accuracy. That is nothing but how many of them are correct. How many are correct? How many are correct? So this logic should be applied for the classification projects. And this logic should be applied for the regression projects. Regression projects always has the difference because numbers, two numbers are there. For example, what will be the tomorrow's temperature? Tomorrow's temperature, actual temperature is 32. I predicted 32.1. Correct prediction or wrong prediction? Means in simple way, it is called as wrong prediction. If you see from the both are same or not, means simply it is wrong. But how much closely I have predicted? Just with a 0.1 difference I have predicted. So prediction, when you are working with the numerical data, it has to be compared with the numbers. So comparison will be done with the error. Error means nothing but actual minus predicted is called as error. Is the point is clear? So here you are having the actual records are number, predicted also number. Sir, if actual is number, but predicted is text, that possibility is not there. To ask that question, that possibility is not there. For example, if I give the MCQs for you, exam I have conducted for you MCQs. Okay, in that for the first question, I asked you to write ABCD. You can't write 25 or you can't write 24.2. You can't write like that. I asked you to predict the alphabet only. I asked you to predict what? Alphabet. You have to predict the alphabet only. You can't predict the number. At the same time, I asked whether what is the salary you are going to get, miss. You have to predict with the number only. You can't say that, yes, sir, you will get this job. I didn't ask yes or no. I asked what is the salary, number. When I am asking my question with number, you have to give the answer also with number only. Similarly, my machine learning models, whatever I have given. So first, whatever the model was applied. If we ask to predict numeric, means it will predict numeric. If you ask to predict text, means it will predict the text. It will not predict the opposite one. Is the point is clear? Everyone understood the logic, guys? So for regression projects, what we have to focus? Error. Error we have to focus. What is our ultimate goal for the regression project? For regression project, okay, what are the prediction we are doing? Now, what is the goal? Everyone tell me what is the goal for the regression project goal? Yes. So for any regression project, our requirement is we want the prediction with minimum error or low error. That is the requirement. So what are the equation? I am not worried about what logics you have applied. My requirement is only minimum error. Okay, what logic you have applied, which equation you have got, from how you got that one, that is not my point. My requirement is only minimum error. Okay, for the given data set, if I give one data set to you, You need to identify the perfect equation. Every time I know, I'm not asking you give the zero error. Understand this logic. My requirement is predict with zero error. I want a zero error. This is not my requirement because every data set will not give the zero. Not possible. If error is there also, I want the least error. I'm not saying zero error. I want the least error. Least. So your algorithms, any algorithm has to be designed in such a way you have to give the minimum error. Is the point is clear, guys? Everyone understood the logic? How the regression algorithms will work means every regression algorithm will work based on the minimum error. Okay, done. Understood, guys? Anyone has any doubts till now? Amir. Amir is asking to repeat. Which one, Amir? Have you attended from the starting, Amir? Starting, have you attended? No. Please go through the recording. By if you have attended means I used to repeat this one. But if you have not attended again from the starting, it is difficult to explain. Just go through the recording once. Okay. So you are having the YouTube link. It is directly right now. It is going on the YouTube live. You can go through from the starting once. This video is also being. Yes. Okay. Right now the video is getting played in the YouTube. In the Naresh IT YouTube channel, it is getting going on in the live. So just you can go with the starting. Amir, whoever has attended lately, just go through the starting. And from the starting, who has attended, if you are having the doubts, please ask me, I will explain. Shiva Krishna, I can see your questions. Shiva Krishna, I can see your questions. You are typing in the questions only and I can see your questions. In this chat box, I can see your questions. Don't use the Q&A. Don't use Q&A. Please use only the chat box. Right? Yes. Next, Shiva Krishna asking, the equation here we are just guessing. Do we have one stable equation which will use for all? That is the one which we are going to work. Okay. As here as an example, I told you, this is a random example. And in that random example, I have given the random equations. And from this random equations, what I have told you is finally, which is the best equation is least error. So finally, your invention. So one project, for example, one algorithm is there. One algorithm you have designed means for what purpose you have to design that algorithm? What is the purpose of designing an algorithm? You have designed something means for what purpose? There should be some purpose, right? For every design. Understanding, Shiva Krishna. Okay, for every algorithm. So here I'm going to explain that different ML algorithms are there. Now, tomorrow you are also inventing a new algorithm. For what purpose you are inventing? What is the purpose? Purpose is what? So regression algorithm or regression equation, something you are inventing means for what purpose? There should be some purpose. Based on that only everything will happen. Same way here also, that is the we are understanding. Understood? So here for any, so here what is the requirement is? My requirement is I want my algorithm. What are the algorithm I'm going to invent or what are the algorithms are there? Every algorithm has to give me the minimum error. That is a requirement. So algorithms, whatever are going to have, everyone has to give the minimum error. How this is going to work? That is only our one by one, step by step, which we are going to have. So how this minimum error concept will work? Now, for example, if you take the errors, 1 minute. Okay. Sudha, Shiva, in example explain it has one input and one dependent. If you have multiple inputs, how the equation will have the variable x for every input, one by one. So here, Sudha, we are going to discuss one by one in the sequential order. Next, Prem Sagar is asking, sir, will you provide project on which party will win and IPL prediction or something? If you are having the data with you, what are the past data is there? Collect the data with you, and automatically we can do that particular prediction also. If you conduct the survey and if you can get the data, 100% we can predict the which party will win. Data is more important. What if we don't give X and Y and just ask it to predict the future values based on the past data? Past data means only X and Y, right? You're saying two things, Shiva Krishna. In your question, what you have written is, what if they don't give X and Y? Okay, you are saying X and Y was not given. X and Y was not given means data is not given only now. Right? Is the point is clear? Now, so here, every algorithm we required is minimum error. What is the minimum error miss? What is error? I told you. What is error? Just now I have told you. What is error? That is actual value minus predicted value is called as error. Now in these errors, you are having the both positives and negatives. Errors will be both positives, positive error will be there, and along with the negative error will be there. Now when some of the positive errors are there, some of the negative errors are there, if you do the average of that error, automatically what happens? Some positive error, some negative error will be nullified. For example, let us assume there are two values are there, two records or something like this. Some input data along with the output. In the output and input and along with the predicted values, this is the error guys. Okay, some records are there. Now for the first one, first record you got the error as -10. For the second record you got the +6 error. Third record you got the +4. Now what is the net error? Finally, what is the average error? What is the average miss? The average is going to be 0. But really it is a data which is not having any error. No, here error is there. But still there is an error also. The average is getting into the 0. Though there is error also, still it is getting 0. So whenever you are having the positives and negatives, you cannot combine both of them so that the value will be nullified. That is the reason what they have done is, instead of considering the plain error like this, why we should not go with the normal error. They have identified the special error for that. What is that special error they have identified? Means for any data set, once you are having the X value as the input, Y value as the output, and whatever you have predicted, something you are going to predict, right? And you are going to calculate the error. That error is nothing but this one minus this one. Now, whatever you have calculated, for that you have to calculate the square. Why you have to do the square means? Because here negative values are there. Negative values has to be converted to positive values. That is the reason they have identified the square. After getting the square, now they all of them are positives only. Everything is now positive. Now they applied the mean over this. That we call it as, which is called as mean square error. Mean square error. So here my required agenda is my MSC, that is nothing but mean square error should be minimum. What is meant by mean square error? Mean square error. What is the meaning of mean square error miss? One more time I am explaining guys. Error miss y minus y hat. Square miss doing the square. Mean miss average. That is nothing but sum of the values divided by total number of values. So ultimately my requirement is to identify the least error of mean square error. Okay, that is the reason. Okay, now here one of the student is asking why we can't take the absolute value. Why you have gone with the this one only. So here y minus y hat for that absolute if you apply also. And if you calculate the y minus y hat for that absolute, for that if you apply mean, what is this is called as mean absolute error. This we call it as mean absolute error. First, sir, why we have to calculate the mean? What is the reason of calculating the mean? Means when you are having the multiple records. If you are having the single record, not a problem. But when you are having the multiple records, always we have to calculate with the mean. Why, sir? Very simple. For example, in this class, what is the students has got the package values? One student has got 6 lakhs. One student has got 18 lakhs. One student has got 9 lakhs. One student has got 7.2 lakhs. One student has got 5.4 lakhs. Should I say each and every student package numbers? Or should I say what is the average package? For example, in your class, 150 students are there. Should I say all the 150 data points for you? If you ask me the question, sir, in your class, what is the package of the students? 150 students are there. Who has got placed? Now, for all the 150 students, should I say the 150 numbers? No, no. Similarly, we can't say for every record, what is the error, right? Every record will have the error. Then every record we can't tell the what is the value. So overall, we have to say overall error is called as mean error. Overall is called as mean error. So here you are having the mean square error, mean absolute error. Out of which we are going to consider this one, mean square error. Okay. And there is a reason behind that. That reason is called as differentiation problem, which I am going to explain in the further one by one in the sequential order. Okay. Now, so here, what is our ultimate goal in the regression project? One more time. We have to predict what I told you, predict with least error or minimum error. Which error? Which minimum error does? What is the minimum error you want? What is the least minimum error you want? That is MSC. You want the MSC as the minimum. What is MSC? What is the formula for MSC? Y minus y hat whole square divided by n. This one we want as the minimum. Everyone is clear? Minimum error is the sum of the squares of error. For that, you are going to divide by the total number of errors. That is nothing but mean square error. For any regression project, the goal is this one. Finally, at the end, you have to calculate the best model or best equation which has given the least error. Which error? MSC as the error. MSC. Every time it is MSC. Okay. Now, for this MSC, once the errors are squared, automatically what happens? The units also will be squared. For example, I have to estimate the house price or car price, or in terms of something, whatever we want to estimate, the prices, sales, anything, whatever you are estimating. For example, house price. House price is, for example, 1 lakh. Okay, estimated value is 90,000. 90,000 is the estimated value. What is the difference? 10,000. What is 10,000 rupees? 10,000 rupees. Now, if you do the square, automatically what happens? Rupees square. Rupees also will be squared. So units will be squared. So units should not be squared, and you want as a normal means. For this, we are going to apply the square root. This we call it as RMSC. So everyone please make a note of one by one. First, error. Starting with the error. What is error means? Difference between the actual value minus predicted value is called as error. Next, we are having the square error. What is square error? Square error means nothing but doing the square of this one. Actual value is represented by y. Predicted value is represented by y hat. So error was represented by y minus y hat. Y minus y hat, we call it as error. What is square error? Y minus y hat whole square is called as square error. Why we have to do? A reason. Why we have to do the square? Because negative errors are there and positive errors are there. Since negative and positives both are available, to convert the negatives to positive, we are doing the square. So we have the both negatives and positive errors. We have negative errors, positive errors, and we want to convert the negative to positive. That is the reason we are doing the square. Next, we are having the mean square error. What is mean square error? Mean square error is nothing but applying the y minus y hat whole square. For square error, you are applying the mean. Mean means sum divided by total number of records. Why we are doing this one? What is the reason behind this? Why we have to calculate this one means for getting the var or error. This will give the individual error. Every record it will give. This will give var or error. The next one we are having is called as root mean square error. What is meant by root mean square error? What is the meaning of root mean square error? Means the root mean square error is y minus y hat whole square divided by the n. Why we have to do this one? Because units are squared. Units are squared in the MSC. To resolve this problem, units are squared in the MSC. To resolve this problem, they came with the solution called as RMSC. Is the point is clear, everyone? Understood? For 1 reason is there. Yes, Joshi, same as standard deviation. In the last class, my regular students who are attending every day, in the last class, I have discussed with you the standard deviation. In the standard deviation, how we compare the value with the mean value, it is called as standard deviation. If it is compared with the another actual value, it is called as error. Right? Next, Prem Sagar is asking why we have to convert the negatives to positive. What is the reason? If you don't convert and if you take directly the average of them, finally I have to take the average now. Finally, I have to take the average, right? For example, assume that errors I have not squared. I have not squared the errors. Okay, assume you are having the y hat like this and y minus y hat, you got the minus 10 plus 6 plus 4. Now, automatically you have to calculate the what are the errors are there. You have to take the average. What is the average of this? That is 0 divided by 5 or sorry 0 divided by 3 records, automatically 0. Error is 0. Even minus 100 plus 60 plus 40 is there. Now also error is, what is the average error in this case? 0. For example, if you got minus 10,000 plus 6,000 plus 4,000, now also error is 0. For all these things, error is 0. Now. This model, three of them are same. Three of them are same. This is one equation. This is another equation. Another equation has given like this. This is your equation 3 and this is has given like this. For three equations, which equation you are going to consider then? Because average error is in the three of them 0 only now. Now, which equation you will consider? I mean, which model you will consider now in this case? Understood, Prem Sagar? Now, if you convert this value as the positive value, now automatically what happens? This total is going to become the 20. 10 plus 6 plus 4, 20. This is total is 200. This total is 20,000. Now, automatically, which is less out of these three? 20 is a 200 or 20,000. 20 is the least one. So, automatically, then we'll identify the equation one. That is nothing but model one. So, when you are having the positives and negatives, we cannot calculate in that way. Prem Sagar, is your question is clear? Why we have to convert the negatives to positive? Yes. Next, converting negative to positive can impact regression prediction. If you don't convert Saida Naik, that is the reason. Though we are doing the this positive to negative, again we are going to convert, right? Normal. So this is the metrics. These four of them are called as evaluation metrics. MSC, RMSC. Okay, they are called as evaluation metrics. What is meant by metric? Metric means formula. Okay, what are the different evaluation formulas? How we are going to evaluate? Measures. Simply to say metric means measures. What are the different evaluation measures we are having? So these are called as evaluation metrics. So, sir, should we remember this formula? By heart, this formula means no need. What is this? First one is called as error. How to calculate error? Y minus y hat. What is S? S means square. Square means square. What is M? Mean. That is sigma by N. What is R? Root. That is a formula. In the calculation also same way we have to calculate. First we have to calculate E value. From that we have to calculate the square of that value. From that we have to calculate the M value. From that we have to calculate the R value. In the same order we have to calculate. Calculation also will be done the same way. Everyone is clear? These are called as evaluation metrics. Evaluation metrics for regression project. These are called as evaluation metrics. Okay, sir. Evaluation metrics, okay. But how to identify the equation first? After equation, next one, evaluation metrics are next one. First equation, right? Now let us focus on the how to identify the equation for the given data. That is the most important part. Now let us focus on that. So how we are going to identify in the infinite number of equations, which equation is the best? So here first they have taken the data, some data, which is X and Y. First I am explaining with the basic example, guys. Later I will add the one more column. Later I will add the large data. And let us do the final project with the big data set. In the sequential order we will do. First only if you take the large data, concepts will be more complex. If you start with the simple data, concepts will be very simple. First you have to start. Remember, when you are learning for the first time, you are expert. First understand this one. Are you expert or learner? This is more important. Learner means first you have to start from the base. Simple examples. You want the simple examples. With the simple examples, you will understand the concept more clearly. But at the same time, you should not stop with the simple examples. Sir, if you explain only simple examples, but in the reality, it is no use, no, sir. Who told to stop here? I told only to learn. Up to learning only, I told. After simple examples, you have to add the dosage. Let us increase the one more. Who asked you to stop with the simple example? Starting point is not the ending point, na. Starting point is only the starting point where you have started the concept. Take the another example, increase the more complexity. Try with the another example. Then you add the one more example. Then you add the one more example. Like that, you practice the increase the dosage of the example. Difficulty you just increase. What dosage you have to increase? Difficulty dosage. Sir, if one column is there, you are saying only one column and one column. If I am having the two input columns, three input columns, 10 input columns, increase the dosage. Opening only if you take the 10 columns, finally the subject will become the difficult and finally we will say that not understand it, sir. So when you are a learner, don't start with the complex examples. When you are an expert, already you know so many things. Now you want to apply your logics. Directly take the large data, apply your concepts. Who is stopping you? Because you already know. But when you are a learner, don't start with the complex one. If you start with the complex one, subject will become the complex. And finally, you say that this is a difficult subject. Basically, that is not the difficult subject. Any subject in this world is easy only. We don't know how to prepare that and we'll make that one as difficult. So as a learner, where you have to start? Simple examples. So that is the reason I'm selecting this example. Why I have selected this example? I can't take any different big numbers or all these examples. Why I have started with this one? Easy to understand. Okay, always start with the easy example to understand. Later you add something. Finally, the concept will remain same only, na? Concept is concept only. Here, if you are having, for example, X 1, 2, 3, 4, 5. what is the average of x? That is, what is the mean value? Mean value is 1 plus 2 plus 3 plus 4 plus 5, which is nothing but 15. 15 by 5, which is 3. Here 5000 is there also. Concept is what? Sum of the values divided by total number of values. That is concept. Concept will not change based on the big numbers or small numbers. So no need to try with the big numbers. Even if you try with the small numbers also, concept is concept only. Is the point is clear? So first I am starting with the simple concept. Later I am going to enter with the difficulty. Like that, I'll explain the multiple examples, guys. Okay, I'll not stop with the one example. I'll explain the multiple examples. Okay, now first, let's start with the first project. We call it as simple regression project. What is the project name is called as? Simple regression project. Now, what is meant by simple regression? Simple regression and multiple regression. You are having the two regression are there. One is called as simple, one is called as multiple. What is meant by simple means if you are having only one input variable, anyways, output is also one only. That too, output is numeric. Output is 100% should be numerical only because regression indicates output is numerical. Simple indicates one input column. Multiple indicates more than one input column. More than one input column is called as multiple. Regression means one output, that too, that output should be numerical, which is continuous. Already I told in the previous class, what is continuous for you. For the new students who are attending as a workshop as the today's class, for them, output is numerical, simple way. Right? Now, so when you are having the more than one, that is like, for example, here you are having the y, which is dependent on the two columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the example. Now in this equation, you have to get y is equal to f of x1 comma x2. Means the right side equation should have the x1 variable, x2 variable also should be there. Example of that one is 4x1 plus 5x2. Some equation like this, which consists of both x1 and x2 should be there, right side. Whereas the example for this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where y is f of x. Means where in your right side only x should be there. Single x only should be there. X means my meaning is 4x plus 9x power minus 2. You take anything, but only x should be there. No other alphabet should be there. Here alphabet should be x1 and x2 alphabet should be there. Understood? Understood the point, everyone? So this is simple regression. This is called as multiple regression. Multiple means more than one input variables. Means your output is dependent. This is depending on this one along with this one. Whereas this one is depending only on this one. For the future data also, for the future data, 6, what is the estimated y value? For this one also, future data, where you are going to get x1 and x2. And they'll give 6, 11, what is the y value? Like this they'll ask. Is the point is clear? Always we are estimating output only. We are not estimating the input. Input you have to give, I'll estimate the output. Is the point is clear? So first let us complete the simple regression project followed by multiple regression project. Multiple, sir, I want that directly the multiple regression project. I'll take the 1 lakh records in the real time in the company. Directly they'll give the 10 lakh records with 100 columns, 50 columns. I want like that. Means with that concepts you will not understand. That is called as application. That is not called as learning. Here you are want application or you want learning. First decide that. Okay. Directly by taking the 10 lakh records, I'll also take the direct real-time data set, 10 lakh records, and I'll apply. Who will explain the max behind that? Step-by-step max I have to explain means for 1 lakh records, when I have to complete the max. If I give 100 values, calculate the mean value means how much time it will take for you. If I give 5 values and I ask to calculate the mean, how much time it will take? There is a difference now. How, which person will calculate in this class for 100 records manually? You tell me how you will calculate manually. Sir, why to calculate manually, sir? Code is there, no, sir. If code is there, how you'll understand what is the max behind that, and how you'll understand in what order they have invented, by what purpose they have invented, and why you have to change like that, how you can understand all these things. Then you will also become the robo blindly to do that one. For example, for this date, if you give this data set to me, I can do manually also. I don't want the Python only. Throw the Python software side. I can do manually and I can show. The only thing is it will take more amount of time. Python code computer na, it will take faster and it will complete. What is the difference between the human versus machine? Machines are as is the humans which can do very fastly. Machine means just a machine which is a substitute of the human to do the work fastly. It is not replacing. It is doing the same thing what we are going to do, but very fastly. That is the only difference. Okay. Is the point is clear, everyone? Now, so let us start with the first project. First example, and let us do the maths behind that and everything. I'm going to start with the simple, perfect and very simple example. As I've told you now, I will go with the multiple examples, but I'll start with the simple one. After this, sir, if here 19 is there, let us try with the second example. First example only we have to try. Second example, not problem. One more example also we can do now. So let us try with first one, this one. Second example, let us try with different number and let us see the difference. Okay. So don't worry, guys. One by one, we are going to do the multiple examples. Point is very simple. Okay. Now, here, first I'm going to have this data. Let us, for this data, how will I identify the equation? Evaluation means okay. That is evaluation, fine. First, I want the equation. How we are going to identify the equation? So any equation has to be invented in such a way, finally the error should be minimum. Which error? Which error? Normal error, y minus y hat? No. Which error? Mean square error or RMSE. Either RMSE or MSE. Either RMSE or MSE. So we have to identify the equation. Identify relation or equation which gives least error. Which error? RMSE or MSE. That is, MSE is nothing but sigma of y minus y hat whole square divided by n. This one I want minimum. Minimum MSE I want. This is minimum which I want. This logic only we call it as least squares method. What is this method name is called as? Least squares method, which is also called as OLS. That is nothing but ordinary least squares method. Simply, I want the least square error. OLS technique name is least square error. Is the point is clear? Ultimate goal is least error I want. Now, here we are having the different types of algorithms are there. The first algorithm they have started with the called as linear regression. What is the first one? Linear regression. That is the first algorithm which they have started. So what they have felt is we want the equation such a way. What are the equation is there? The equation should be linear. What is meant by linear means a linear line. Okay. Yes. As one of the student is asking to scroll up. Guys, you are writing the running notes, right? Everyone. Please make sure that you are writing the running notes. And wherever you are missing the notes, please ask me to scroll up so that I will scroll up. What is the difference between the simple regression and the multiple regression means? Simple means one input variable, multiple means multiple input variables. Regression means output is numeric. Okay. Now, identify what are the data set was provided to us. What are the data set? Any data set, whether it is 10 records, whether it is 10,000 records, whether it is 10 columns, whether it is 10,000 columns. Irrespective of columns, irrespective of records, Finally, our requirement is to get the least error. Our prediction should have the least error, irrespective of the size of the data. Right? Manish, sir, some topics from first not written. Where? Which one? Okay, now I'm going to start with the linear regression. Now, what is linear regression? The linear regression is nothing but relation between input and output is linear. Linear regression means the relation between the input and output should be linear. That is called as linear regression. This is the first algorithm. Guys, again I'm saying first algorithm. Like that, they have started from this algorithm to almost 10 algorithms are there in the regression. We are going to discuss all the 10 one by one in the sequential order. Okay. Now, this is the first one where they have started with the identifying the relation between input and output is linear. So input and output linear means nothing but, so here you are having the data which is called as X and Y. Okay, what are the data? Now tell me, this data is called as simple or multiple? Simple. Okay. So simple and simple data. Simple data means where you are having, why it is called as simple? Because of 5 records are? No, it is why it is simple? Because of one input variable. It is not based on the records. It's based on the columns. One input column is there. So that is the reason it is called as simple. Now, for this simple data, I am applying the linear regression. Then what this algorithm is called as simple linear regression. What is meant by simple? One input column. What is linear? The relation between them is linear. What is regression? Output is continuous. One word, one meaning. Okay. Now, so what are the output variable which is continuous or which is numeric? I want the relation in such a way y is equal to mx plus c. That is the linear equation. I told you the relation between y is input and output should be linear. Y is equal to mx plus c. Now, sir, what is meant by linear? Okay. Ruby is asking the question, what is the difference between regression under ANN and what you are discussing? Ruby, that is ANN is deep learning, what we have discussed in the class, our class. This is ML. I told you not different algorithms. Okay. For example, Ruby, I'm going to give one data set for you. And for that data set, I ask you to apply the logic. What are the pattern is there? I ask you to apply the pattern. You will apply one way. Another person will apply another way. Another person will apply in another way. What is the difference, miss? Algorithms. So one algorithm, one way of logic. Which one is best, miss? Which has given the final least error? That is the best. That is only called as model selection. Understood? Right? So linear regression means y is equal to mx plus c. So here y is equal to mx plus c. What are we are having? Yes. Shiva Krishna. What is regression? One input and one output. Okay. If you are having one input variable, that is called as simple. Regression means output is continuous or numeric. Linear means the relation between them should be a linear. This one, a relation should be like this. Is the point is clear? What is meant by linear? So here, that is the next one. So here, what is the relation between the x and y should be? The relation between x and y should be linear. What is meant by linear? What is the difference between the linear line versus non-linear? So here, linear equation means what is meant in the maths, what is meant by linear means which is straight line. Which is a straight line. Non-linear means which is not a straight line. Other than non-straight line, they are called as non-linear, a line which is non-straight line. So for example, you are having the straight line like this. That might be this one, this might be this one, this one, this one, this one, and this one. Anything is fine, but straight should be there. Whereas non-linear means this one, this one, this one. These are all called as non-linear lines. Okay. So now for the linear lines, what are the linear is there? The relation between the x and y should be only 1 mx plus c. This is the only equation. Only one and only equation. For non-linear, we are having the ax square plus bx plus c. Y is equal to ax cube plus bx square plus cx plus d. Like this, we are having the multiple. Y is equal to e power x minus 4x plus 9x square, something, anything, no restriction. Everything are non-linear only. Linear means the equation should be only y is equal to mx plus c. What is meant by linear? Linear means y is equal to mx plus c. Y is equal to mx plus c. Okay. So now I want the relation between x and y in this format. The m value is unknown, c is unknown. This only you have to identify. But format should be y is equal to mx plus c. Means literally to say, I want the equations like this. 4x plus 9 minus 2x plus 6, 4x minus 10, 19, something. But equation should be in such a way mx plus c only. It cannot be another equation. Only mx plus c. That we call it as linear regression. Is the point is clear? Linear regression means y is equal to mx plus c format. Now, so as I've told you, I want in this format. So when I want in this particular format, now automatically I'm going to calculate least error. What is meant by least error? This is predicted value or estimated value? Estimated value. What is predicted original value? Y. So y minus y hat whole square, that is sigma by n. This should be minimum. That is y minus y hat is nothing but mx plus c. Mx plus c I am substituting here. That is whole square divided by n. Now sigma of y minus mx minus c whole square divided by n. This one should be minimum. Now, out of infinite values of m and infinite values of c, you have to identify the which is the best value. How to identify the best value means which gives the least error, minimum. So when they have applied the minimum for this equation, okay, they want the minimum error for this equation. Okay, understanding guys, everyone? Yes or no? Everyone understanding? So first you have to understand from where we have to start. From where we have to start, we have to understand. Where we have to start means what we want to predict or what we have to estimate. For what purpose we are doing this. First you should know that. From there, remaining things will start. Okay, sir, I want to understand this one more time with a different example. Means always think with a one more example. For example, you want to design a car. One car you want to design. Where you will start the design of the car? Starting with the doors and output you will start up. From where you will start? First you have to think. Right. What is the expected output? Designing a car means any person will design. I'll also design the big doors, this data, and what are the shape of the car is there. Instead of keeping like this, I'll keep the car mirror like this. Why you have to keep the car mirror only slightly like this? Why we can't keep the car mirror like this, like lorry, buses, everyone will have the straight only. Why cars only will have like this? We can keep like this also, na? I will start like that then. I will start designing my car with a straight mirror. And inside 2 mirrors are there. Now, instead of 2 mirrors, I'll keep 4 or 5 mirrors like lorry. Means mini size lorry I will create and I'll call it as lorry. Car. This is also a design only, na? So first you have to think for what purpose we are designing a car. Purpose. Sir, I want the mileage or I want this much of speed. First, you have to keep that one in your mind. For what purpose you are designing. And in your car, how many people has to sit? These many people are going to sit. 5 members are going to sit. Okay, 5 members. And along with the some luggage, which is having the total weight of 600 kgs approximately. Overall 600 kgs maximum weight. This is max. So I want to design a car which can carry 600 kgs with this much of speed. If it goes for 1 liter, it has to give minimum 20 kilometers per liter. This is my requirement. That is your requirement. 600 weight of something weight of 600 kgs has to go in the car with a liter of 20 kilometers. So this is my requirement. For this requirement, I'll start designing. Obviously, I'll get my car will not have this much of value. Only 18 kilometers it will give. Then what I'll do, some modification I will make. It has given for that modification only 16. Then again, what I'll do, some more modification. Like that, I will do the modifications. Finally, I will require my goal. Whatever the goal is there, that goal I have to achieve. So same way, the same logic will be applied in the ML or in the AI or anything. First model is not the best model. First design is not the best design. First, they'll get some errors. That errors they'll rectify. Again, they'll get new errors. That errors they'll rectify. Like that, they'll rectify, and finally they'll design the final out. Is the point is clear? So similarly, now coming back to our regression project, what is our requirement? Again, I'm asking, what is our requirement? Identify the best equation which has given the least error. Identify the best equation which has given the least error for the prediction. That is the requirement. First requirement is clear now? Least error means what error? Y minus y hat O square sum divided by n. This one should be minimum. This is clear now? Root means per error or means per error. Anything is finished. For example, means per error is low means automatically root means per error also will be low now. For example, means per error is 100. What is RMSE? 10. Now, if you reduce this MSC to 90, what is RMS? Increase or decrease? This will also decrease. If you still decrease to 40, what happens? This will also decrease. If you decrease to 10, this will also decrease. If you decrease to 4, this will also decrease. As one you decrease, MSC decrease, automatically RMSC will decrease. Automatically RMSC will decrease. Finally, RMSC only. Okay. Now, my sum of the squares of errors or mean square error should be minimum. My mean square error should be minimum or RMSE should be minimum. RMSE or MSC, both are same. Okay, one is low means automatically other is low. Okay. Now, so here I'm going to substitute the equation y is equal to mx plus c. Why mx plus c only? This is linear regression equation. For non-linear regression, another equation. For another regression, another equation. For every one regression, one equation is there behind that. So for linear regression, y is equal to mx plus c. Y is y minus mx minus o squared divided by n. This should be minimum. Is that clear, everyone? Understood or not? Yes or no? In order to get this one as the minimum, what they have done is dy by dx they have applied. That is nothing but called as differentiation. In order to get the minimum error, they apply the differentiation dy by dx. When they have applied the differentiation like this, automatically m value you have got like this. In what way the m value you have got means sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square. And c value is equal to, okay, what are the c value is there? That is nothing but mx minus, what are the c value is there? You got in terms of m into x bar minus y bar. Y bar minus m into x bar. That is the c value. So what is m value? M is slope. What is c? What is c means coefficient. Do you remember the max of linear equation, y is equal to mx plus c. Everyone can remember the max, where m stands for slope, c stands for the intercept or coefficient, or which is also called as y-intercept. If you remember, okay. If you can't remember, miss, I'll explain that. Everyone can remember, yes or no? Or if you don't remember, miss, I'll tell you. Very simple, guys. This is your graph sheet. 1, 2, 3, 4, 5, something. -1, -2, -3, -4, +1, 2, 3, 4. Similarly, -1, -2, -3, -4. Something you are having like this. Right? Now take any one straight equation, one straight line, anything of your choice, straight. It should be straight. Either this one, or this one, or this one, or this one. Anything is fine, but straight should be there. Straight one. So now if you take one straight, okay, one straight line. For every straight line, the slope will be there. This is called as slope. Okay. This slope is high or this slope is high. That is called as slope, slantiness. Okay. So that is nothing but slope. This we call it as slope, which is m. Now this line will cut somewhere on the y-axis, somewhere it will cut, right? Wherever it is going to cut on the y-axis, this distance is called as y-intercept. The line, if you extend somewhere where it is going to intercept the y-axis, it is called as y-intercept. So that is the it is called as y is equal to mx plus c. Everyone make a note of this. Now, here what is x bar? X bar means mean of x. Y bar means mean of y. Okay, mean of y. Y bar is called as mean of y. X is called as mean of x. And finally, you got the equation like this. From where you got the m value, from where you got the c value means by substituting dy by dx of this one. Why you have to take this one only? Mean square error. Why mean square error only? So everything are connected. Now you understand the logic. Why we have came in this order. Why I have explained for you MSc first. This is the reason. Now I'm going to take one data set. Now for you only calculate for this data set what is the m value and c value, and you only tell me the which is the best equation that gives the least error. Out of infinite equations, which has given the least error, you only tell me. X, Y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and I want the equation y is equal to mx plus c format. Now, multiple values are there. Out of multiple values, which is the best value, which is the best for this one, which gives the least error, means calculate. How to calculate? First, m value. How to calculate m value? So first I'm calculating the x bar. Tell me what is x bar? 1, 2, 3, 4, 5. What is x bar? 3. What is the y bar? 8. Everyone is okay? Now, I request everyone not to write along with me. Just focus so that you'll understand more easily the equation. And after the equation was completed, I'll show in the Python. You'll say that, oh, this is the backend code. Simple. Okay, understand the logic clearly with the basic example. Now, here you are having the x bar and y bar. First, I'm going to start with the x minus x bar. What is x value? 1. 1 minus 3. What is 1 minus 3? Minus 2. 2 minus 3. Minus 1. 3 minus 3. 0. 4 minus 3. Plus 1. 5 minus 3. Plus 2. First x bar was completed. X minus x bar. Next, I'm going to calculate y minus y bar. 6 minus 8. Minus 2. 7 minus 8. Minus 1. 8 minus 8. 0. Plus 1. Plus 2. Right? Next, I'm going to calculate the x minus x bar into y minus y bar. That is -2 into -2 plus 4. -1 into -1 plus 1. 0 into 0, 0 plus 1. Again plus 4. Next, I'm going to calculate x minus x bar whole square. That is this one. Whole square is 4, 1, 0, 1, and 4. Okay, everyone. Can you teach again x bar? X bar is nothing but average. Average is nothing but sum of the values of x divided by total number of values. Sum is 1 plus 2 plus 3 plus 4 plus 5 divided by total number of records are 5. That is 15 by 5. Why you got the 3? Is that clear? Done. X bar means nothing but average. Mean. Mean means average. Okay. Now, just I'm writing this one also in the orange color. Sir, why you are writing orange color? I'll tell you. What is the reason of writing the orange color? I'll tell you. Okay, now I'm going to calculate the slope. Okay, first I'm going to calculate the slope. What is the slope? M value, which is nothing but sum of x minus x bar into y minus y bar divided by sum of x minus x bar whole square. Now, sum is nothing but total of this column. What is the total of this column? That is sum of this column. Sum of this column is nothing but 10. What is the sum of this column? X minus x bar whole square. What is the total? 10. So 10 divided by 10. What is the value? 1. Next, y-intercept. Next, I am going to calculate my y-intercept, that is C. That is y bar minus m into x bar. That is y bar. What is y bar value? 8. 8 minus m. M is 1. And what is x bar? 3. So 8 minus 3, which is equal to 5. Now, finally, my equation. What is my final equation for this given data set? Y hat is equal to mx plus c, which is 1x plus 5 is the best equation for my data. Understood? Again, I am requesting everyone, please don't write. I'll give the time for you to write. Understood this one? Now, same thing as it is. Okay, just wait for 1 minute. You can write the remaining things. Just wait for 1 minute. Here, I'll show you in the Python also same thing. Okay. One minute. Just hold on, guys. Python. Just I'm showing in the Python so that after showing in the Python, I'll give the time for you to write. Right now, have you understand now? Though you have not written also, still you have understood, right? My system has got hang. This is special effect. Till now, it is working suddenly by it has shifted. Done. Yeah, yeah. Done. Just I'm going to select this one. So for our simple understanding, just I'm using the Google Colab. Okay, because again, if I show VS Code or something, instead of that, directly just I'm using the Google Colab, right? As an example. Yeah, just after this, I'll give the break. Just wait for another 5-10 minutes in order to get the break. Let's have only for 5 minutes, 5-10 minutes. It will not take much amount of time. Max will take so much of amount of time, but Python will not take that much of amount of time. So first, here I'm going to import the pandas as PD. Okay. And who knows already the Python? Only for those students who doesn't know what is Python, please don't ask what is pandas or all these things. Okay. Just x is equal to 1, 2, 3, 4, 5, comma, y is equal to, and I'm going to give the 6, 7, 8, 9, and 10. Okay, this is my data frame, which I have created by using the 2 columns. Okay, same data set, right? So just now, what are the data set we have chosen here for our understanding purpose? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same data set I have taken, right? Now, for this data set, just I'm going to apply the linear regression. What are the linear regression I have told you just now? The same thing I'm going to apply. From sklearn dot, from sklearn dot linear model, I'm going to import the linear regression. I'm going to import linear regression. And what are the linear regression I have imported? I'm writing that one as model. Model is equal to, okay, my linear regression. Okay, this is my linear regression. And model dot fit. I'm applying the fit. Tell me guys, what is meant by fit? Calculate. Now let us see what it will calculate. So I'm going to give the input as X. My input data is X. And what is my output data? Y. Y column. And once I have given the input as X and output as Y, and I'm asking to model.fit. So X is caps lock or small letter, small caps lock. Okay. Let's give this one as caps lock. Okay. Linear regression was fitted. Now let us calculate the model dot. Okay. First one is nothing but slope. What are the slope we are having? Model dot slope and model dot, that is first I'm going to calculate the coefficient. Now what is the coefficient you got? 1. That is m value. Coefficient is nothing but m value. And I'm asking the model dot intercept. Model dot intercept. What is the intercept value? 5. This is 1. This is 5. My question is, in the backend, what it has calculated? In the backend, what it fit means calculate. What it has calculated? What it has calculated means here, whatever I have written in the orange color, it was calculated. That is the reason earlier I have changed this to orange color. Okay. So exactly in the fit, what happens means this is the one. You have given the data like this. This is the data. And you ask it to the machine to apply. And automatically the machine has applied all these things and simply calculated 1 and 5. Is the point is clear? What I have done with the orange color pen, the same thing was done in the back end of the fit. Now you can write. Everyone, you can write now. That is, this is the data. X is equal to 1, 2, 3, 4, 5. Y is equal to 6, 7, 8, 9, 10. Now you can write how it is calculated the slope. That is nothing but coefficient value. As per the Python, slope is called as coefficient. And this is called as intercept. Yes. Here, okay. Now, let me take few questions, guys. Okay, before taking the few questions, let me reduce the size. I think any previous is there? Above? Above you have to write. Above is nothing now. Equation you have already written, right? Everyone has written the equation. After the equation, you are going to write the node max. What is the max is there? Just you are going to write the max. This is what exactly it is going to have the fit. When it is applied the fit, model.fit in the fit calculate. Calculate means what exactly it is going to calculate. Linear regression will calculate like this. One more algorithm is there. For that max is different. One algorithm, one max. Okay. Coefficient means slope. Intercept means this one. Slope and intercept. Right? Of course, I'm going to show you show the Python code. Amir. Now, Sai is asking the question, why we have considered RM, we have to consider RMSC, right? Why you have considered MSC? That is the question by Sai. Sai, now you tell me, if RMSC was reduced, I mean MSC is reduced, automatically RMSC will be reduced? Yes or no? Simple. Now I'm focusing on MSC also. Indirectly, I'm focusing on RMSC only. Na? If MSC is, I want the minimum MSC. Minimum MSC means literally equal to minimum RMSC only, right? Yes. Both are directly proportional to each other. Next, Sindhu is saying that why df of x should be 2D. Sindhu, why x should be 2D? Because x can be single input variable or multiple input variables. X can be input single or multiple, whereas y should be only single. Is that multiple output variables are possible? No, only single column is output, whereas input can be either single or multiple. So that is the reason they have locked with the 2D for the input, 1D for the output. So always your input should be 2D array. Input should be 1D array. I mean, input should be 2D array, output should be 1D array. Sindhu. Then next, Virendra. What about non-linear? We'll discuss Virendra. Shiva Krishna. Why you have taken x bar as 3 and y bar as 8? You tell me, Shiva Krishna. For this data set, what is the average value of x? For this data set, what is the average? If here 14 is there, then also it is 3. Yeah? No, average. I have calculated average, guys. Shiva Krishna, that is average. For this particular column, calculate the average. For this particular column, calculate the average. What are the average is there? This average is 3. For this particular column, average is 8. Average value. X bar is average of x. Y bar is average of y. Done, everyone. Fit meaning is clear now. Fit means calculate. What it will calculate? These formulas it will calculate. From where you got these formulas? From where you got? That is the question. All these things, formulas is okay. Directly I can tell you the simply it will calculate these formulas. But first question you'll get in your mind, sir, why these formulas you have got? I can't say directly simply fit on x comma y, input and output. I can't say simply like this. And what is the formula behind that means? This is the formula, write directly the formula I can say. How you got that formula? How you got miss? By dy by dx of sigma of y minus y bar whole square divided by n. My question is why you have applied dy by dx in order to get the minimum? Why you applied this one? Because you want the minimum MSC. Why you want MSC? Because errors are negatives and positives. For everything, reason is there. Is that clear, everyone? Instead of doing the blindly, why we have started from there means this is the reason. Understood or not? Yeah, not still it is not the break time, guys. Just wait for another 2 minutes. Here, point number 1, X. X means input columns. X means input columns. Y means output column. For simple regression, X will be only one column. For multiple regression projects, X will be more than one more than one column. For simple regression projects, Y is one column only. In multiple regression projects also, Y is one column only. Y is always one column. One column is single column will be selected by selecting like this. This is one column. Where you are having the X with multiple columns means multiple columns is called as 2D. X is possible with the 2D. Y is never possible with the 2D. So that is the reason X is called as 2D array. Y is called as 1D array. That is the reason why we have to consider for X DF of one more bracket of X. What is the difference between this one versus this one? This is 1D. This is 2D. Right? Why we have to consider double bracket like this? Because 2D. Sir, why 2D, sir? For this example, you are having only X and Y. Okay, only X and Y is there. Okay. Assume you are having the A, B, C, and Y. Now, in your X, how many input columns are there? Three. What are the columns? A, B, C. How you are going to select them? List of A, B, C. Obviously, we have to use one more now. So 2D now. How you are going to select here? The same way, one column, which is 2D. Is the point is clear, everyone? So your input should be always, sir, in a simple way. Now in the Python code, sir, I want the Python code still more simple. Miss, before this one, after this, you write here one more. Your input I is equal to df of x, which is always 2D. Write like this. Your input should be always a 2D array. Okay. Next, your output O is equal to, what are the output is there? O is equal to O single byte where output is 1D array. Okay. And execute this one. And here you write the, what are the df of this one? Sorry. Capital X. I have taken capital of X, right? Done. Now here you write the fit comma I comma O. What is I comma O? Input comma output. Is that clear now? Everyone please make a note of the code. Of course, my students already know that you are going to receive that one in the Google Drive. In your Google Drive, you will receive the notes automatically. Now it is clear what is meant by model.fit means. Not only linear regression, guys. Tomorrow, if you learn the non-linear, when you apply the fit, what is the code behind that? What is the max? What is the max? For example, day after tomorrow, you will apply one more algorithm decision tree. What is the max? One more algorithm. What is the max? For every algorithm, when you apply fit, it will calculate something. What it will calculate? Exactly what it will calculate, why it will calculate, how it is calculated, and from where it was started. We want everything, right? Understood? We don't just want the Python code. Clear, guys? Now, let's take with the another example. For this example, this is y is equal to 1x plus 5. Okay, everyone is clear? Now, what we have done is called as model. model or identify the equation. We have identified the equation. Now we have to do the evaluation. What is modeling? Modeling means identifying the relation between them. Identify the relation between X and Y. That is nothing but your input and output. Between the input and output, you are identifying the relation. That we call it as modeling. That equation is called as, what are the equation you got? This equation is called as model. The process is called as modeling. When you apply the fit, max will apply now. That max is called as modeling. Output, what are you have got finally? Y hat is equal to 1x plus 5. Y hat. It is not Y guys, Y hat. Y hat is equal to 1x plus 5, which is called as model, ML model. ML model or linear regression model. Now using this model, we are going to do the prediction and evaluation. We are going to do the prediction and evaluation. That is nothing but this is our data set. They have given the data set like this. For this data set, you have to apply the prediction first. Let us go with the prediction. After the prediction, we will do the evaluation. Two things we are going to do now. With that, algorithm will be completed. We'll try with the another example. Let's increase the dosage of the example. Next one. Okay. Now, before to that, first we'll go with the prediction. What is meant by prediction? Prediction means nothing but substituting the X value in the equation. What is meant by prediction? Substituting X values in the model. So substitute 1. Where you have to substitute? In the Y hat, 1 is equal to 1x plus 5. There you have to substitute 1. X value 1. When you have substitute X value is equal to 1, what is the output you are going to get? 6, 7, 8, 9, and 10. Is the point is clear? This is called as prediction. The code for this one is model.predict. Model.predict on input data. What are your input data is there? Just you are going to apply the model.input. And it is going to give the 6, 7, 8, 9, 10. From where you got these numbers? By substituting the X values in the equation. This is the code. Now, what is the column name you are going to give for this? Some column name you have to write, right? What is the column name? Let us add the column name as Y hat. What is Y hat? What is the meaning of Y hat? Predicted values, that which is called as Y pred. So here also I'm writing the same thing. What is that this one? I'm storing this one in the name. Some name I have to give, right? Y hat. This is okay. Y hat. So in the Y hat, I'm storing the values. 6, 7, 8, 9, 10. Done. Now, what is the next one I told you? Evaluation. What is meant by evaluation? Comparing actual and predicted values is called as evaluation. Now, which one we have to calculate? MSC. How to calculate MSC now? Tell me how to calculate MSC. First y minus y hat, that is 0, 0, 0, 0, 0. Followed by y minus y hat whole square, that is again 0, 0, 0, 0, 0. Now MSC, how to calculate MSC? Sum of y minus y hat whole square, sum divided by n, that is total is 0, 0 by 5, which is 0. This we call it as evaluation. This is prediction, this is evaluation. That is modeling. 3 of them. Modeling, prediction, evaluation. 3 of them. Now, what is the code for this? Let us see the code. Please don't write simultaneously. I will give the time so that, because first let us focus, guys, please. Okay, from SQL and dot metrics, I'm going to import the mean squared error. I'm going to import the mean square error. And within the mean square error, mean squared error, inside this, I'm going to give the original y values, and also I'm going to give the predicted y values, that is nothing but y hat. My original y values, what is the name I have given? Wo, output. Original output, I have given the name y. What is the name you have given here? Wo. If you are interested, you can write here x, caps lock x, and let us give this one as y. Okay. And here also we'll substitute with the x comma y. Always input will be given as x, output will be always given as the y. So here also I'm writing the y and y hat. Automatically, what is the error? 0. How you got that one? What is the backend of this? This is the backend. Prediction backend, evaluation backend, modeling backend. 3 of them are clear? Understood, guys? Everyone? Since it is a small data, I have calculated everything manually. If I have chosen the large data, when I have to calculate manually, that is the reason I have chosen a small data set, that too easy example. Sir, why you have not taken the 30, 40.5 something miss? It will take more amount of time to calculate. Only difference is time increase. Nothing else. Time will increase. Dhananjay, what are the input function was created? According to the input function, we have to give the input. The what are the function is there? According to that, we have to provide the input. Now in the interview, what they'll ask? From this, what they'll ask interview? Python code they'll ask, Max they'll ask. What is the interview questions from this? Means interview questions is, what is evaluation metrics of regression? Question number 1. What are the different evaluation metrics of regression? You are going to say MSC, RMSC, and square error, everything. Now they'll ask why we have to consider only RMSC or MSC. That is the next interview question. So next they'll ask in terms of what is meant by OLS technique, ordinary least squares method. Full form, okay. What is the meaning? I mean, what is the meaning of that? I didn't ask what is the full form of OLS. Okay, meaning of that. Meaning is, sir, identifying the prediction values or estimating the values which gives the least square error. What is the OLS? Least square. What is least square? Least square error. Square error should be minimum. Right? So like this, the interview questions would be there. They will not ask the max. What is the formulas? What is the formula for M value? What is the formula for C value? Could you do everything in front of me? These are not the interview questions. Interview questions is in terms of why you have to select this one only. Is that clear? Everyone, residuals or errors, anything is fine. Yeah, Indra, I'm going to upload in the drive. So modeling, prediction, evaluation, 3 of them are clear. Now, can you do the same thing for a small data set of different data? Let us increase the dosage as I've told you now. What you have to do? What are the things you have to do? Modeling. What are the data I provided? You have to do the 3 things. What are the 3? Modeling, prediction, and from that prediction, you have to do the evaluation. 3 things you have to do. Automatical evaluation you have to do means prediction compulsory. Prediction you have to do means first equation is compulsory. Okay. Now I will provide the one data set. For that data set, you calculate and tell me. That too linear regression, and your answer and Python answer should be the same. 1, 2, 3, 4, 5. Y is equal to 1, 4, 9, 16, 25. Now, countdown starts 5 minutes. Modeling, evaluation, and prediction and evaluation, everything with linear regression. Five minutes. with linear regression. I want linear regression. First, tell me what is the model. Model means equation. After that, you tell me what is the predicted values. Paul, y is equal to x square. That is linear regression. Huh? Paul, that is linear regression. Huh? What is the question I asked Paul? Question, Paul. What is the linear regression model? Model for linear regression. I didn't ask non-linear regression. There is no square here. Obviously, only mx plus c only. Square is not there. Psi. I asked only for linear regression. For the given data set, if I apply linear regression, what is the answer? That is the question. Fast. Modeling means calculating M and C value. What is modeling? Linear regression. For linear regression, modeling means calculating M and C values. Is called as modeling, which is called as fit. Model.fit means it will calculate M and C. Prediction. Prediction means substituting the values. Substituting X values in equation. And calculating Y hat. And calculating the Y hat is called as prediction. Evaluation means comparing the Y hat with Y. Comparing Y and Y hat and calculating from this MSC value. MSC and RMSC. MSC is calculated means automatically RMSC is also calculated. So I want three of them. Modeling, prediction, evaluation. Complete. Prediction also, evaluation also. Calculate MSC till MSC. Now what you are doing, Python also has to be the same answer. Both should be the same. Everyone completed? After this, we'll increase the dosage and we'll go with the real-time project. We'll try with the real-time project after this. Third example is real-time project. With that, simple linear regression will be completed. We'll go with the multiple. Later, we'll go with the multiple. So what is the data was provided? X 1, 2, 3, 4, 5. Let me do simultaneously along with you. 1, 4, 9, 16, 25. Okay. X bar. X bar is equal to 15 by 5, 3. Y bar is equal to 25 plus 16, 41, 50, 54, 55, 55 by 5, 11. 1 minus 11, 10, 4 minus 11, minus 7, 9 minus 11, minus 2, 16 minus 11, plus 5, 25 minus 11, 14. Total of this one is minus 19, plus 19, correct? Wait, x minus x bar into y minus y bar. 10 minus plus 20 plus 7, 0 plus 5 plus 28. Total of this x minus x bar into y minus y bar. 33, 33 plus 7, 40, 60. Total is 60. Which is equal to 60 by 10, which is 6. C is equal to y bar minus m into x bar. That is 11 minus 6 into 3. 11 minus 6 into 3 is 18 and minus 7. So my equation is y hat is equal to 6x minus 7 is my equation. This is my equation. Everyone has received the same 6x minus 7. Y hat is equal to. Let's cross check. Let's cross check. So here, just my input is as is, output is 1, 4, 9, 16, 25. These are the values. Now, my input data will remain same. That is this one only, re-execute. I'm going to apply fit. Now, let me calculate the coefficient first. That is m value. What is the coefficient? 6. Intercept value, which is minus 7. Correct. Perfect. So 6 and 7. So my equation is 6x minus 7. How it is 9? Y bar minus m into x bar. Y bar is what? 11. 55 by 5 na. Right? Everyone is clear? Now, let us, after mod, this is model. Model was completed. Model is 6x minus 7. What is the next one? Prediction. X 1, 2, 3, 4, 5. Y 1, 4, 6, 1, 4, 9, 16, 25. Now, 1 I will substitute here. 1 is 6 minus 7. What is 6 minus 7? Minus 1. 2, that is 12 minus 5. 12 minus 7 is 5. 3 substituted. 3 means 18. 18 minus 7 is 11. Next, 24 minus 7. 24 minus 7 is 17. 30 minus 7, 23. So predicted values are minus 1, 5, 11, 17, 23. Let us cross check in the Python. Minus 1, 5, 11, 17, 23. Correct. These are the values. Now, once minus this is calculated, now I'm going to calculate the y minus y hat. Now, y minus y hat, 1 minus of minus 1 plus 2. 4 minus 5 minus 1 minus 2. Again minus 1 plus 2. Y minus y hat whole square. 4, 1, 4, 1, 4. Sum of y minus y hat whole square divided by n. 12 plus 4, 14, 14 by 5. 14 by 5 is, which is equal to 2.8. And let us cross check in the Python. It is 2.8. Perfect. Answer is same. My answer, Python answer should match, not Python answer, my answer. My answer should match the Python, not Python answer by me. Modeling, prediction, evaluation. 3 of them is clear. Automatically RMSE. This is MSC. RMSE is nothing but root of y minus y bar whole square divided by n, which is square root of 2.8. I don't know exactly. I have to open the calculator. Those are simple numbers I have calculated. This is not simple number, so I don't know. 2.8 square root 1.67. That is a value. In the Python also, you are going to simply apply the same thing. right? Square root of 2.8, which is you are going to get this one. Now, why we have discussed this example? Because for the same data, let us apply non-linear regression. Now, let us apply non-linear regression. So, whatever this data, which is x is equal to 1, 2, 3, 4, 5, y is equal to 1, 4, 9, and 16, 25. For linear regression, you got the 6x minus 7, and with the RMSE value of 1.67 and MSE value of 2.8. Now let us calculate for the same data non-linear regression. This is linear. Let us calculate non-linear regression, which is x square. For example, if you have got and RMSE, you assume that you have got 0. Now, which one is best? Linear or non-linear means this we call it as model selection. So first we applied the first model, that is linear regression model. Later we applied the non-linear regression model. And finally we selected which is having the least error. That concept is called as model selection. First only you know that linear regression is best or non-linear is best means I don't know. So first I'll apply in the sequential order. How many algorithms are there? Every algorithm I'll apply in the sequential order one by one. And which algorithm has given me the least error, that one I'll select later. First only I don't know that. So this is the equation. By seeing only to say this is small data, we can say y is equal to x square. For every data set, you can say, I'll show one more data set. Tell me which linear regression or non-linear regression works. You tell me by seeing only. If you can tell by seeing only means tell me for this one. Automatically you don't understand. So here I'm having one data set. Okay. For this particular data set, now tell me, okay, sir, here multiple columns are there. Okay, I'm going to convert this multiple columns into one column. Okay, let us take like this. Yeah. I'm going to take the total spend, that is nothing but this one plus this one plus this one. Okay, now you are having the two columns, guys. These are the two columns. Now, for these two columns, this is X. This column is X for you. This column, let us take as X. This is Y. Now, X is there, Y is there. Now tell me, equation you tell me, and linear or non-linear you tell me. Now everything you tell me. Which is best one and what is error? By saying only we can say no. So then what we are going to do? We are going to apply first linear regression between these two, linear regression, and we'll calculate the RMSE. What is RMSE? And we'll apply the non-linear regression also, and we'll calculate what is RMSE. Which has given the least error, that one we are going to finalize. Once we have finalized, out of these two, one of them will finalize, right? For example, this equation is besta, this equation is besta. Once we have decided which one is best, only one we are going to select, and that selected only we'll use for the future data prediction. For example, here you are having like this. This is one equation, and you are having this is one equation, and which you have got the RMSE as 0. Assume. This I have not explained. What is the max and what is the formula I have not explained, just as an example. Linear regression is there, non-linear regression is there. Out of these two, which is best, miss? Non-linear is best. For the future data, you have to predict. Now, which equation you are going to select for your future data? This equation is there, this equation is there. If you select this equation, answer is 6 into 6. That is 36. 36 minus 7. 36 minus 7 is 29. 29 is the estimated value with the linear regression. 36 is the estimated value with the non-linear regression. Which is correct estimation, miss? Non-linear is best because that has given the least error. So whichever the model or which equation has given the least error, that is used for the future prediction. But before to that, we'll try all the equations. How many equations are there? Every equation we'll try. Every possibility of algorithm we'll apply. And including the ANN. Including the ANN. Pooja. Including the ANN, we are going to apply every logic. And later, finally, we are going to decide which one has given the least error, and that we are going to apply. And we are going to predict from that for the future data. Everyone is clear how it is going to work? For the future data, if you are having the multiple equations, which equation you have to finalize? Which algorithm you have to finalize? The algorithm which has given you the minimum error, that one you have to finalize. With that only you have to predict. Is the point is clear? Yeah, Indra, that is neural networks. Basically, don't ignore for you. That is ANN is artificial neural networks. Since we already completed for one of the batch and that students are attending here, so they are asking that question. Please ignore. That is not relevant to you. Just ignore. Everyone is clear? This is the max behind the ML. Sir, max is required or not required? Now tell me, according to the Python code, max is required or not required for Python code? For Python code, max is required? Not required. Simply, it will only calculate everything. But what it will calculate only? Max. Sir, max is simple or difficult? In this, simple is there or difficult is there for you? I'm not writing additions and multiplication, subtractions. Is there anything else other than that? What I've used? X minus X bar. What is X bar? Average. Average means which is called as sum and division. My adding division I have used in the X bar. In the X minus X bar, what I have used? Minus. In the X bar, X into X bar into Y minus Y bar, what I have used? Multiplication. Other than plus minus division, did I use anything? Less and minus only, na? That is the same reason I told less than 10th class max is required. Everyone is clear, guys? Understood the logic? Done? Anyone has any questions? If you have any questions, please, you can ask what are the question you are having. Who are having the questions till now? You can ask the question. If no questions, we'll increase the size of the data and we'll execute that one. Now I'm going to take 500 records. For 500 records also, logic will remain the same. Even for 500 records, 5,000 records also, logic is same one. Formulas are same, prediction is same, evaluation is same. Everyone is clear, guys? Please ask what are the doubts you are having. Done? So we'll continue from here with the next class directly. Instead of having the break and something, we'll continue from the next class. If you want the real-time project, new students, you have to register for the course. Existing students, automatically you'll get the new project. And we'll execute the real-time project with the large data, linear regression, non-linear regression. So how many we are going to do is simple with simple linear. That is one input, one output by applying y is equal to mx plus c. Next, we'll do the simple non-linear also. What is non-linear? Non-linear means equation changes. Data set will be the same. Next, we'll go with the multiple linear. What is multiple linear means? You are going to have the multiple input variables with one output variable. Input variables will be more. And we are going to apply all these things one by one in the sequential order. Obviously, in the real life, we are going to get the multiple only. Along with the multiple, we'll have the multiple columns. Multiple columns, so many records. And that is the real time. So we are going to do with the real-time projects and we are going to do the end-to-end project with that. If you're not having any question, you can leave. As I've told you with one example, I have explained for you today. What is the today's agenda? Just before leaving. Okay, before leaving. What is the agenda for today's class? If you scroll back in the starting, I told you. I'll explain what is the max behind that, how the machines apply the algorithm on the given data, and what is the Python coding. 3 of them I have shown you.
one question.
Yes.
Here one contact but related to this only. If we want to find out the beginning path, then we have shown that if we simply divide differentiate the square, then we get the millimeter. So why do we need gradient descent algorithm? If we can
That is gradually decreasing the error. Gradient descent means gradually. You are decreasing the error. When you are making the trial and error, that concept of gradient descent will come.
But here we are not gradually.
No. That logic, when you're applying the decision trees, when you're applying the ANN, these concepts, when you're applying, like you're working from the boosting point of view, you're asking. In the boosting, that logic is applied because multiple models are there. Na? Errors always has to reduce. There, that logic will be applied, not here.
Okay, simple linear regression.
Not. Simple linear regression will not have the gradient descent. If it is there, I'll explain. Yes, everyone, my students, existing students, you can leave. Existing students, you can leave. Who are the new students are there, stay back and ask what are the doubts you are having. Now I'll take your non-technical questions also. My existing students, you can leave. Virendra, if we have the large data also, we are going to load the data into the Python by using the library pandas.read underscore CSV, read underscore Excel. Like this, we are having the different functions to load the data. Virendra, in the pandas, we are having the various functions to load the data. Next, all the new students, please ask what are the doubts you are having. When will the ML will start for the new batch? Prem Sagar, ML will start after 8 weeks. Once we complete the entire Python, then ML starts. Because you don't know, if I show the ML code, you will not understand the ML code, right? Import pandas as PD. You know what is pandas? What is meant by as? So all these things first has to be completed. Done. 5 minutes. Others, waiting for your questions, guys. Ask all your questions. And some of the students are typing in the Q&A. Yeah, Sagar. Really liked this regression class and your last week master class on machine learning also. Your explanation with basic maths made it simple and clear. Thank you. Ravichandra, thanks for your compliment. Thanks. Akshay. Akshay, your question is clear. Earlier, what are you have typed in the Q&A? Abhimanyu, already class was completed. You can leave. If you're not having any questions, you can leave. Archana, sir, I don't see the notes. Also, I'm not sure if my messages are going to. Archana, I can see your message and you're saying that Google Drive is not available. I have not added till. In the next few minutes, it will be added. In the Google Drive, you'll receive the notes in the next few minutes. Akshay, why will use the MSA and RMSA as evaluation metrics? RMSC only. Finally, RMSC only. First MSC, from there RMSC. Root over that. First we calculate this, from there we'll calculate. Finally, RMSE will calculate. Okay. Archana, just wait for another 10 minutes. You will receive the complete notes. Just wait for 10 minutes. Okay. After the session close 10 minutes, not now. Sorry. For example, meanwhile, if some of the students are asking me, first I'll clear the doubts. At the end, last 10 minutes, I'll add. Right, guys? Anyone? Any questions? Online students waiting for you. When we'll get the recording? Generally, the recording will be uploaded in the next day, morning 10 o'clock or 11 o'clock. But today's class recording is available in the YouTube. Naresh IT YouTube channel, it is available. Sampit, what you will cover in the ML? Regression, classification, clustering, association rules, recommendation engines, and forecasting and dimension reduction. All the techniques, the complete ML techniques, whatever are there, everything will be covered with more than 25 plus algorithms. 25 plus algorithms we are going to cover exclusively from ML. Samprit. Done. Next. Just whoever the students are there, I'm going to share you this ML textbook also. Okay, as you want the reference, some book. So I'm going to share the books also for your reference in the Google Drive. Okay, Suresh, I'll share. Janvi, so I kindly ask the admin to share all the demos from the day one. Yes, you can contact the admin number. Admin number was shared here, right? Everyone, whoever the new students are there, you can contact the admin so that you'll receive the content, syllabus copy, and along with the recording videos, the previous class recording videos. Contact the admin 9133343369. Lena, admin. Suresh. Hi, sir. This is my first ML class. Can I work on this concept in Python directly? 100%. All the 25 algorithms in the ML, within the ML, we are going to cover 25 plus algorithms from various techniques. Okay, like in that, one of them is regression. From regression, some algorithms. From classification, some algorithms. From forecasting, some algorithms, that is time series forecasting. From clustering, and we are going to have from the association rules. Okay, association rules. All these things I have explained in the previous class. What is the meaning of association rules and everything, and recommendation engines. From all this, we are going to learn 25 plus algorithms with 6 end-to-end projects. 25 algorithms with 6 end-to-end projects. What are those 6 end-to-end means? One end-to-end project from regression. Today's what we have discussed is an example. We are going to cover the 6 projects, 6 end-to-end projects, ML projects. Within the ML, we are going to have the 25 algorithms and 6 end-to-end. One is from regression, one is from classification, one is from forecasting, clustering, association, and recommendation. So 25 algorithms with 6 ML projects we are going to cover from ML. Is that clear? Out of which one algorithm was completed today, only one was completed, but project was not completed. Example only completed. Project we are going to do in the next class. Example was completed, not project. Project means multiple steps has to be included. Done, everyone. I think now it will be clear for you what is Max and how it is going to work and how the machines will identify the patterns, everything. Right? Done. Thank you, guys. If no questions, you can leave. I have 12 years of experience on SQL Server. Once I have completed this course, can I add 3 years of experience? Please suggest. That is your choice. How many years you want to add? That is your choice. But surely you are going to become the experienced professional. That is for sure. In the real time, whoever the person is going to work with 3 years of experience, who is really having the 3 years of experience, how much work they are going to do in the industry, surely that much of work you are going to do. That is for sure. Subject wise, 100% will have that much of subject. Sufyan, how old are you? Instead of how old are you, how much experience you have? That would be a better question. I have 14 years of experience in IT. Okay. For your question, direct answer I cannot give. That is my personal. You should not ask age, salary, weight, height, all these things. Wanted to compare myself, sir. No comparison. Right? Done? Thank you. Thank you all. Take care and bye. I'm around 40. Congratulations on successfully reaching 40 years of age. But I will not tell my name. Okay? Done, guys. Thank you. Jokes apart. Thank you.